So I'd like to demonstrate how to draw a proper chair structure and also how to add the 12 bonds to that chair structure, because each time we have a 6-carbon ring, we're going to have 12 bonds coming from it, whether they're all hydrogens or some of them are methyls and ethyls and the rest are hydrogens. There are always going to be 12 bonds coming from our chair structure. So Dr. Klein does a great job showing us how to draw a proper structure in the textbook. He wants us to start with a shallow V. Then from one end of the V, we make a not quite vertical line, and that goes not to the middle of the V, but about halfway to the middle. And now we're going to start to draw parallel lines with lines that are already existing in our drawing. So this one is going to be parallel to this line here. So we draw a parallel line there, and then another parallel line, and the last parallel line. So if we look at this, the first line we drew is parallel to the fourth line we drew. The second line is parallel to the fifth line, and the third line is parallel to the sixth line. And that's how every chair structure should work. You don't need to get out your colors all the time, but I think it's useful to just demonstrate the parallelness of the 3 pairs of lines in our chair structure. And of course, the chair structure is essentially our way of looking at a cyclohexane ring from the plane, within the plane. As it's drawn like this, we're looking from the top down, and that would be from the top down onto this parallel ring structure. And if I were to identify bonds here, these would be the blue bonds, the red bonds would be right here, and the green bonds would be here. So the chair structure is just a way of representing the cyclohexane ring in a 3-dimensional fashion. Once we have a chair structure, we know that there are 2 bonds to every carbon, so we need to be able to draw those in their proper locations. So let me get another chair structure here. And I'm going to try again. So sometimes it takes a little bit of effort to Okay, I'm going to go with this one. So what we're going to do we're going to draw axial bonds, and we're going to draw equatorial bonds. And the axial will always be vertical bonds, and the equatorials are sort of horizontal. I'm going to draw all the axial bonds on my chair structure first. First, I want to point out that these 3 carbons, as we alternate around the ring, have what I like to think of as an upward orientation. They're all sort of at the top of a mountain, if you will. And so their axial bonds are going to be straight vertical. So I'm going to draw some carbon-carbon bonds or carbon-hydrogen bonds that are straight vertical, just like that. And then if I use a different color, these 3 carbons in the ring are all sort of at the bottom of a valley, or downward-facing carbons. And those carbons will all have axial bonds that are perfectly downward-facing, all still vertical, right? So the line is still vertical, but they are all downward-facing instead of upward-facing. So those are my axial bonds. 3 of the axial bonds are always straight up, and 3 are always straight down. And now if I again go back to the parallel bonds in the ring, those are going to help me draw my equatorial bonds. If I look at those blue bonds will dictate this equatorial bond. And it's going to be parallel to those blue bonds, pointed out of the ring. And same with this equatorial bond as well. Those are parallel to the blue bonds. If I look at my parallel green bonds that I originally showed you a few minutes ago, this equatorial bond is parallel to the green bonds. It's downward facing. This equatorial bond is parallel to the green bonds and it is upward facing. And lastly, the red. The red bonds have an equatorial and upward facing substituent there, and a downward-facing equatorial substituent right there. So you'll notice that for an up carbon, we get up axial, down equatorial. And for a down carbon, we have down axial, and we have, in this case, up equatorial. And that's how we're going to draw the 12 substituents on any cyclohexane. There are 3 up axial bonds in black, there are 3 down axial bonds in purple, and then there are 6 equatorial bonds, 3 up and 3 down, and the equatorial bonds will always be parallel to a set of carbon-carbon bonds in the ring. Each carbon has an axial and an equatorial bond, and the orientation of those bonds will be dictated by the orientation of the carbon. This carbon is an upward carbon, so it has an upward axial and a downward equatorial bond. And then the down carbon, of course, over here, has a downward axial and an upward equatorial bond.